Hello everyone, I'm presenting this video as a part of my final project of the course Network Science and Application of Professor Wu at the University of Florida. The topic of this project is digit recognition based on MLP. I'm trying to make this explanation simple and understandable to comprehend. The agenda of this presentation is as follows. First is the introduction, followed by algorithm, implementation, conclusion, reference, and finally the MetaLive demo. First is introduction. The introduction consists of neural network, deep learning, multi-layer perceptron, and PCA. Neural network has a very broad application prospect, particularly in the field of pattern recognition, intelligent control, and system identification. Deep learning's concept is based on artificial neural networks. Multi-layer perceptron with multiple hidden layers is the kind of deep learning structure. MLP is a feed-forward artificial neural network model, which is a mapping process to transfer input data into a set of appropriate outputs. Principal components analysis is a kind of data analysis technology. The most important application is to simplify the original data. The second part is the algorithm. I mainly introduce and describe two algorithms in this presentation, which are PCA, Principal Components Analysis, and MLP, Multi-Layer Perceptron. Backpropagation is the main algorithm of MLP. The principal component analysis is a statistical analysis to perform dimensionality and noise reduction. It can be analyzed from the main factors of multiple things, revealing the essence of data, simplifying the complex problem. Suppose there's a sample data set, X, and D is the features number of each sample. Then we compute the covariance matrix of the sample matrix by the first formula, where n is the number of samples, c is the covariance matrix. Next, now diagonalize the covariance matrix by the diagonalization formula. When we perform PCA, we should choose the number of features p, so we maintain the eigenvectors corresponding to the top biggest p eigenvalues. According to the above formulas, the dimension reduction is done. As we see in the figure, the red line is the direction of biggest variance, so we should project the data on this direction to maintain the biggest principal component of the data. The next algorithm is MLP. To help us understand, we should define some parameters first. Wji is the weight from the hidden layer to the input layer. Wkg is the weight from the hidden layer to the output layer. Bj and netj is the bias and input of number j neurons in the hidden layer. Yg is the output of number j neuron in the hidden layer, and yk is the output of number k neuron in the output layer. In this project, we use the Heaviside function as the activation function. And as I mentioned before, the backpropagation is the main algorithm of MLP, and the mean square error is used as an error criterion. BP is the most common and effective algorithm which can be used to train artificial neural network. The forward propagation process is that the training dataset is inputted to the input layer first. After the processing in the hidden layer, the data will get to output layer and show the results. Since there exists the error between the estimated value and the actual value, the error should be calculated and back propagated from the output layer to the hidden layer until it is propagated to the input layer. In the process of backpropagation, the values of various parameters should be adjusted according to the error, and iterated the process until the convergence. The third part of the presentation is the implementation of MLP. The data we use is the MNIST handwritten digit dataset, which has 60,000 training samples and 10,000 test samples. The 50,000 to 60,000 data of training samples we use as validation data. First, we should plot the learning curves of training and validation data. When iteration number is 10 and 200, the learning curves are plotted as below figure shows. As we can see, these two learning curves converge all the time because the cost function is used as a feedback backpropagated to the upper layer to adjust the width to reduce error. With the increase of iterations of training, the error becomes smaller and smaller. What's more, from the above figure, we can see that these two learning curves almost coincide with each other. The reason is that when training is carried out so much time, the training property is more and more in accordance with the training data, namely overfitting. Since the training process is based on training data, the validation cannot be fitted as well as training data. Then we record the accuracy of this system to test the performance. Since we perform 10 iterations, every iteration brings about different successful recognition number. We put them into one table for convenient observation. As we can see, with the increase of number of iterations, the accuracy rises up to 95%. Then we change the iterations number and plot the accuracy curves of training and validation data. The curves are shown as follows. According to the above figure, we can see that the accuracy is rising all the time. However, there's a fluctuation of validation data accuracy curve. The reason is also due to the overfitting I mentioned before. Next, we change the number of principal components and hidden layers units and record the corresponding accuracy values. When we keep the hidden layers units as 200 and change the principal components, we say that when principal components number is 40, the accuracy is highest. And next, we keep the hidden layers unit. We keep the principal components unit as 50 and change the hidden layer units to 125. The accuracy was the highest. The next part of the presentation is conclusion. The design in this presentation achieves the handwritten digit recognition. By using multi-layer perceptual model, the MNIST data has been recognized and classified to corresponding digit groups. This paper is also mainly focused on designing a MLP model with one hidden layer. Training data is used as a training sample to update weights. Validation data is used to test the performance of the whole system through cross-validation. The accuracy of this design is about 95%, which implies a good recognition performance. The next part is the reference. And thank you for your watching, and then I will show the MATLAB demo to you. And now I will explain some part of my codes to you. This number is the number of principal components, and I choose 50. This is the hidden layers unit, 200, and I will iterate this process 10 times. This is part of initialization of weight. And then MSE is the mean square error of training data, VMSE is the mean square error of validation data. This part is forward propagation of MLP. and the width from input layer to hidden layer and hidden layer to output layer will be updated by these two sentences. I have already run this code to save time, and now I just plot the learning curves of training data and validation data to you. As we can see, this is the learning curve of training data. And the blue one is the mean square error of validation data. The two learning curves coincide with each other, as I mentioned before. Now I will show the code of plotting accuracy curves of training and validation data to you. The principal component's number is also 50, and the hidden layers unit are 200. And I will iterate this process for 20 times. The success is the accuracy of training data, and the success 2 is the accuracy of validation data. Now I will plot the curves to you. This is accuracy curves of training data. And the red one is the curves of validation data. Now the presentation of my project is over. Thank you for your watching.